This tutorial demonstrates contacts between bodies using SimXpert. The purpose of this tutorial is to show the user the difference between glued and touching bodies in an assembly while using two different analyzing methods. This is an introduction into contact bodies that shows the very basics by making use of the default contact settings. In this tutorial, you will learn how to mesh different bodies, how to constrain bodies using contact options, how to set up and run linear and non-linear analysis, and how to actively compare results from different analyses side by side. Make sure that you are in the Structures workspace, and on the Tools menu, select Options and change the units to Standard SI. Highlight cutting port under Geometry and select both Create a plot for each body and Import geometry with subassemblies. This will create separate part in the model browser for every parasolid bodies instead of loading the whole model as one part in SimXpert. Import the parasolid from the folder in which it has been saved, then rename the part to describe the body they represent. Double click on part bolted plates P1 in the model browser under Assembly 2. Change the title to Bolt 1, then click OK. Repeat the step to rename the parts as Bolt 2, Bolt 3, bottom plates and top plates respectively. Under Materials and Property, click on Isotropic in the Material group. Create the steel property with its Young modulus, its Poisson ratio, and density attributes, then click OK. Now create a property for solid elements. Click Solid in the 3D property group. Click in the Entities text box and select all 5 parts by clicking Select All in the picking filter. Click on the Material box and select the steel in the model browser created earlier, then click OK. To create 3D deformable bodies, under LBCs tab, select Deformable Body in the Contact group, enter contact body name Bolt 1. Click in the Pick Entities text box and select Bolt 1 from the model browser, then click Apply. Repeat these steps to create 3D deformable bodies for Bolt 2, Bolt 3, bottom plates, and top plates respectively. Please remember that if you use Apply up to before create top plate, click OK to complete the tasks on the last part. Now we need to define the relations between body pairs. The primary benefit of permanent glued contact is the joining of two dissimilar meshes. Click on the table in the contact group. Name it Glue All. Notice that the parts are numbered from 1 to 5 in the left column. The number in the top row corresponds to that in the column. The T's in the cell stand for touch. Click on Glue All and notice that all the T's have changed to G's. G stands for glue. Then deactivate diagonals to eliminate self-contacts between the bodies. Click on the G's and notice the contacts between different parts. Repeat these steps to be aware of the part interactions in the text box below the table. Do not skip these very important steps. Since the bolts will not come into contact with each other, we will remove the contact definition between the bolts. To remove the contacts between bodies, double-click on the symbols in the cells. Do the same for all the remaining contacts that are technically not possible to occur. Now we will need to apply the constraints. Nodes that are connected to a solid element have only translational degrees of freedom. Therefore, we will use a pin constraint. Click Pin in the Constraints group, select the outer face of the bottom plate, click OK, then turn on the detail rendering. We now want to distribute a lifting force of 450 newtons randomly selected and applied over the end of the top plate. One can convert the force to pressure. Select Tools, click on Statistics, rotate the model so that the outer face of the top plate is visible. Then highlight the face and select the outer face of the top plate. Right at the bottom of the information panel, there will be a value of an area. This represents the value of the facial area of the top plate. Now click Exit on the information panel. Note that in this SimXpert package, we have the option of using either the total load or the pressure approach, but cannot use the force in LBC alone, because the force applies a load magnitude to each node on the selected face, making the total applied load dependent on the mesh density. To create a load, click on Total Load in the Load group, click in the Entities text box, select the outer face of the top plate, and enter a value of 450 newtons under the Scale Factor text box. Then enter the direction of the total load as 0, 0, 1 for X, Y, Z coordinates respectively. Now turn on the detail rendering to see the direction of the load. We now want to create a solid mesh for the plate. Under the Meshing tab, click Solid in the Auto Mesh group, click in the Solid Body to Mesh text box, and select the top and bottom plates. Enter a value of 5 mm for the element size. Select Quadratic and click Apply. Create a final mesh for the bolt. Click in the Solid Body to Mesh text box, clear, and select the 3 bolt. Enter 2.5 mm for the element size. Select Quadratic, then click OK. Create a new Nastran job. Enter linear contacts as a job name. Select Linear Static Analysis. If desired, click on the folder icon to specify your location, then click OK. We now need to specify the analysis parameter. Right-click on the LBC's container and Select Contact Table. Select Glue All from the model browser, then click OK. To modify your simulations, right-click on the solver control and select Properties. Highlight Output File Properties. For Nastran DB options, select Masters Only. For binary outputs, select OP2, then click Apply. Expand contact control parameters, highlight contact separation parameters, choose stresses for separation criterion, then click Apply, then close. Note that this is a very important step. To create a contact output request, right-click on the output request, select Nodal Output Request, and create Contact Output Request. Click OK, then run the analysis. Always remember to check your FO6 file. After the job is done running, attach the master file, then click OK. Under Result Type, click on Deformation, highlight Result Case as C1, Statistics Subcase. Under Result Type, highlight Displacement Translational, then click Update. Zoom in and change the orientation to have a better view. Under Plot Type, select Fringe, Static Subcase, Stress Tensor under Result Type, and Van Mises under Derivation. Click Hide, then click Update to view it without deformation. Change the view to make it more visible. We can now see that we have maximum stress of 252 megapascals, where the plates overlap. This is because the two surfaces are glued at this location. To create a fringe plot of contact status, click the Plot Data tab, highlight Case SC0 Static Subcase, highlight Contact Status under Result Type, then click Update. Give yourself some time to view and interpret the results. Click Hide when finished. Exit the State Plot Property Editor. We now want to do a non-linear analysis to investigate the difference between glued and touching contact. In the previous analysis, we assumed that the plates were bonded together, leading to an inaccurate result. In this analysis, we will do some modifications to allow the plates to separate. Create a contact table so that the bolt will be glued to the plate, but allowing movement between the two plates. Click on LBC's tab, select Table, name it Glue Bolt, click on Glue All, and deactivate diagonals. Double click on the parts which can never be glued to each other, like the bolt. Click 3 times in row 5, column 4 to change it to touch. This is because you want the plates to be touching each other, meaning that they can separate, representing real-life behavior. Notice that the touching body is the bottom plate and the touch body is the top plate. Click OK and specify the analysis parameters by creating a Nastran job. Name it Nonlinear Contact. Select General Nonlinear Analysis under Solution Type. Select your directory and click OK. Collapse the Linear Contacts job tree. Double-click on Contact Set Default under LBC's container. Deselect Smart Update. Under Contact Entity, select Glue Bolt, then click OK. Make sure that the state plot box right at the bottom of the model browser is unchecked. Under LBC's container, click on Select Stable, select Glue Bolt, then click OK. Click on Load Case Control. Right-click underneath the default load case. Under Generic Control, type in a total time of 1. Click Apply. Highlight Stepping Control Parameters. The stepping type is fixed. Give it an incrementation number of 2. Click Apply, then Close. We now need to specify the output request. Right-click Output Request and select Nodal Output Request. Select Create Contact Output Request, then click OK. Right-click on Software Control and select Properties. Highlight Output File Properties. Under Nastran DB option box, select Master Only and click Apply. Under Contact Control Parameter, highlight Contact Separation Parameters. Select Stresses under Separation Criterion. Click Apply, then Close. Run the analysis and always remember to check that the job is done. Check whether the job has converged by using the Find option and also scroll down to check that the job is done. Then attach the master result file. Go to Result tab, select Information. Under Result Case, there will be 2 result analysis. Select the second, Collapse Directories, and click on Time equal to 1. Select Displacement Translational under Result Type, Non-Layered under Layer, then click Update. Zoom in to view the separation between the plates. Go to the Deformations tab. Under Default Conditions, the True option is always selected with a value of 1. Change it to a higher value, then click Update. This has no effect on the result, and it is just done to exaggerate the deformation. Go back to Fringe, follow these steps, then Update. We can now see that the top plate deforms right up to the bolts with a maximum stress of 603 megapascals. Now show linear contact result. After doing this, go to Window, open New Window, then select Tile to view the 2 windows side by side. Now select all the parameters to show the nonlinear contact result under Fringe. Click on the Frame of the Structures window to make it current. Then click Update. We're now able to develop a case study having both the analysis results side by side. This concludes the SimXpert tutorial. This tutorial was brought to you by ESTEC, Engineering Technology for Better Business.